If you are watching this video, it is because once again, we are snowed out and are going to have to settle for a video lesson. And Gypsy is here to help me with my lesson, so I trust that she's going to be running back and forth in the video. But what we want to do is we want to take a look today at, we're going to skip over 7.4, which is word problems. We're going to come back to that on Monday when we're back in school. But we're going to hit on special types of linear systems, and then we're also going to go into systems of linear inequalities, and we've looked at systems of equations. So I want you, this one's pretty simple. We're not going to spend tons of time on this one, but on page 417, you will notice example number 1 gives us two equations, a system. And it is 2x plus y equals 5 is equation number 1. 2x plus y equals 1. And you should notice that when 2x plus y equals 1 or 5, this is standard form. How do we get it to y equals mx plus b form? Well, we have to move some things around. So once we move this around, we end up with y equals negative 2x plus 1. And the second equation is going to be y equals negative 2x plus 5. I put them in opposite order there. But now, as you're looking at this, what I want you to tell me is what is similar about those. A couple of things. We have positive y's. We have positive y-intercepts. But we also have the same slope. And when we have the same slope, what does that mean? When we have the same slope, it means that we have parallel lines. So if you determine that ahead of time, then you know your lines have to be parallel. And if they don't turn out to be parallel, then you've done something wrong in your graphing. So I want to take a look at the second, or at the checkpoint there at the bottom of the page. And that checkpoint is how we're going to practice doing this. So we have x plus 3y. I want you to write it in your notes as I'm going so you can follow along. X plus 3y equals 4, and 2x plus 6y equals 4. Now, we can't look at anything on here and make any determination about parallel lines. We actually have to do some work to get this ready. And so we are going to take a look at this first line. We're going to move the x over. So I'm going to have 3y equals negative x plus 4. Now, am I ready to go? Gypsy says no, we're not ready to go. And Gypsy needs to just sit tight for a second and join in the math fun, right, Gyps? So what we need to do here is we want to divide by the 3, divide by the 3, divide by the 3. Once we divide by that 3, we're going to get y equals negative 1/3 x plus 4/3. Now I want you to do the same thing with the second one while I let Gypsy go in another room. So do the second line and I will be right back. Okay, I assume that you've come up with the answer, and while it's quiet here for a minute, we will try to make sure that we have the same thing. So in the second one, I'm going to erase all of this. In the second one, the 2x plus 6y equals 4. Again, we're going to move the 2x. And I'm going to end up with 6y equals negative 2x plus 4. I have to divide by the 6, divide by the 6, divide by the 6. And I'm going to have y equals negative 2/6 x plus 4 over 6. Now, you might be saying, well, Mrs. Jernigan, I thought they were supposed to be parallel lines. But if you reduce each one of those, you're going to find that you come up with a negative 1/3 here. And that negative 1/3 is then going to mimic the 1/3 that you found up here. And so there you do have the negative. And so what you are doing is noticing that you have, and actually this should be a negative x as well up here. So it should be negative 1/3, negative 1/3. If you see that, then you know you've got parallel lines. So what I want you to do now is take a look at example number 2. And this is a linear system with infinitely many solutions. Now, when we do this, when you come up with, and I'm not even going to work through this because I think you're going to be able to look at this and know pretty quickly what's going on. The top equation is negative 2x plus y equals 3. The bottom is 4x plus 2y equals 6. And when you do that manipulation on that bottom equation, what you actually end up getting is y equals 2x plus 3, which is the same equation. It looks differently before you reduced it and before you manipulated it. And that's where you would, if it ends up being the same equation, then you know you've got infinitely many solutions, and that is what you would write for your answer. So what I want to do is have you do the homework. If you take a look, I believe I have you starting at number 10 on page 420. You're working through some of the similar things that we've just done. And then you are looking at page 421 and you're doing 17 through 22, I believe. And that one's going to ask several different questions. There's going to be a no solution possibility, one solution, infinitely many solutions. And what they want to know, it says use the graphing method to tell how many solutions the line has. So what do you have to do there? Graphing method, you're putting 2 lines on the graph. We're looking for that point of intersection. And if they're parallel lines, will they have any points of intersection? No, they won't have any. So that's going to be your no solution. Parallel lines, and you probably can determine that before you ever put them on the graph, but please put them on the graph for me. Parallel lines are going to have no solution. Infinitely many solutions is where it's the same line. You manipulate it and you figure out, oh, this is x plus y equals 6. This is x plus y equals 6 too. That means it's crossing at every point on the line. It's the same line crossing itself. One solution is that point of intersection that we're looking for. So you have 3 possibilities in 17 to 27. One solution, lines intersect. No solution means they're parallel. They're never going to meet. And infinitely many solutions means they're the same line, just on top of each other. So take a look at that, work on it. We will have a time for questions and answers when we come back to school on Monday. But for now, take a look at that. And then tomorrow I have another video for you, which is systems of inequalities. And it's a little bit different than what we've done so far. We're still putting graphs on the line, but we're starting to look for places where the shading intersects. So we'll take a look at that tomorrow.